It's my privilege and it's a pleasure to host JB Poline as our speaker today. JB is an associate professor currently in the Department of Neurology and Neurosurgery at McGill University, also in the Montreal Neurologic Institute. He's the co-lead of the NeuroHub project. That's a web-based data science platform for storing data, for computing data, for collaborating among investigators. It supports research in a variety of domains in neuroinformatics, genomics, social science, biology, and much, much more. Beyond McGill University, JB is chair of the Technical Steering Committee for the Canadian Open Neuroscience Platform, CNPI, which hopefully we'll hear about during his talk, and also at the Montreal Neurological Institute and Hospital called the Neuro. He's active in participating in neuroimaging and neuroinformatics leadership and research. JB's research started early during his career as one of the early pioneers of fMRI research. And he was one of the co-developers of SPM, if any of you have heard of that. Today, he remains a lead researcher in the field of fMRI with a focus on imaging genetics, studying the effects of genetic variations on brain structure, function, and connectivity. And also he devotes much of his time and energy in developing neuroinformatic technologies for big data research approach to neuroscience. His focus on open science has really been making a major impact on the field today. He's a leader of international organizations providing guidance on neuroimaging and neuroinformatic developments. And that includes some of the organizations that you are familiar with, such as Organization of Human Brain Mapping, and some of the organizations that you may not be familiar with, such as International Neuroinformatic Coordinating Facility, or INCF. He's a proponent and advocate of the FAIR Data Sharing Initiative, lead contributor to the dialogue of reproducibility crisis in scientific research. And he's a leading advocate for the collaborative development of standards covering a variety of data sharing initiatives. So let's welcome JB to give us a talk on cultural and technical issues regarding reproducibility in brain sciences and possible individual and community responses. Welcome, JB.
Thank you very much, Lee. This is a way too kind and grandiose introduction, as you probably will see from my talk. Yeah, let me share my screen. And as soon as I share that, I probably will lose the chat and the so I would really appreciate if there are questions in the chat, please just interrupt me. Lee, if you can just say, hey, JB, you have a question. I would rather have that talk a bit less formal and more like a conversation, if possible. Yeah, this was a word on my side. I was more for the students. I should have put that for the students, but let's dive in what I want to talk to you today about, which is this reproducibility and what we can do, crisis, and what we can do about it at a different level. This is my lab. There's about 12 people, and what we do is data analysis project. We also do a little bit of a method development, and as Lee was mentioning, some infrastructure and tools, and there's a strong links between those three areas. And we are funded by a number of institutions, including Brand Canada, NIH, the Neuro, the HPHL, CFREF, Canadian mechanism. So what I'll do today is, first of all, give you a little bit of a background of why I think this reproducibility, where it comes from, and what is the rationale for it, and basically look at the issues and what we can do to answer it. So what's the background of this reproducibility? I would say in life science, where even more than neuroscience. And I think, and sorry for those who have already heard me, I usually take that example as the first one, which is this little pharma would try to replicate 53 papers that were published in very high profile journals with groundbreaking and very interesting results. And they spent about 2 years, 2 to 3 years to actually try to replicate all those results, in Cell, published in Cell, and also all those, like Nature Neuroscience papers, and basically could replicate only fully about 10% of those. And partly maybe 20%, and they really tried hard. Like, they actually asked the researchers to come in their lab to do their experiments and all those things to make sure that they couldn't. So that was a bit of a wake-up call for NIH. And in our world, like more recently, for instance, when you look at meta-analysis, for instance, in unipolar depression and neuroimaging studies, you do find sometimes, and it's not always the case, but you do find sometimes that despite having like 100 of papers being published in individual studies with, in this case, like 99 individual neuroimaging experiments, you do sometimes not find any actually significant result across all those things. There's a huge variability of results, and the question is really what is happening, why this is the case, and what we can do about it. So I do think that the problem is kind of widespread. There's still some very visible researchers that don't think that is actually a major problem. And that's not my opinion, but I want to say that there are different opinions on that question. And I think, for instance, like even the Lancet editor really wrote a scathing editorial at some stage where he was saying like, we have to stop torturing our data to get p-value which is significant and all those things, because that is not helping us in the long term. So NIH actually responded a bit to that problem. And if you have written or participated in writing in grants, NIH grant, there's now a bit more of a guidance and a push to address the rigor and possibility of the application. And I think it is really going in the good direction. And before I want to delve a bit more in the sort of the reproducibility and what it is, let's have a quick terminology, thing, which is basically I use the term reproducibility as a umbrella term for different things, and those things can be like lack of replication when you're having the same method on different data, or lack of robustness when you're having the same data but different pipelines, and all those things are really like one thing, which is how are your results going to generalize to another context? It could be another data set, it could be another same kind of methodology but not exactly the same pipeline. It could be it could be like what if you change scanner? What if so what are the directions? What are the axis of generalization that you can sustain in your claim when you're going to publish your result? So that is the kind of the broader aspect. So what are the issues? Can we try to go and say, okay, what are the exact issues that lead to those problems? And I've divided, and it's a kind of an arbitrary division. There's a spectrum, but this is a bit of an arbitrary division, which is looking at the statistical procedures, looking at the data and software issues, and I will delve a bit more today on the cultural aspects of how is our academic system working, and what is actually possibly incentivizing non-robust research. So in terms of statistics, I think the first thing to say is basically that this is there's a long and huge literature on the p-hacking problem. The p-hacking is, as you know, is basically I've got a bunch of data. I need to find results in those things. I will ask slightly different questions in slightly different angles, and do some different procedure to get some result. and it's very hard when you've spent, let's say, 6 months of acquiring data to actually say, okay, there's nothing there. I just I have to either try to publish a non-significant result, like or actually so there's a like a psychological aspect to it. There must be something in those data that is, and I think most people who are p-hacking are just doing it with in goodwill and good intention in some ways. Like it's just like the procedures are okay. And you have forgot to take that covariate, and that must have an effect and all those things. So that's how p-hacking is occurring. It's really not, I think, intentional fraud at all. It's really like a practice incentivized by our by research. There is a number of solutions, but the key one is really register what you're going to do to the data and what are the questions that you want really to answer in terms of like a null hypothesis testing framework. So that pre-registration technique is now more and more accepted in several journals, in many more, it used to be only one journal a long time ago, but now it's kind of like, you do find like quite a few journals that are accepting. You're going to publish exactly the acquisition, the data analysis steps, and then if that pre-registration is accepted, it's going to be reviewed, and if that's accepted, then you're going to publish the result, whether there are non-significant or significant, in terms of statistics. So I think it's a good procedure, and even just for the sake of thinking about exactly what you want to ask and how you're going to ask it, it's really a nice way of working. The key aspect, which I will emphasize a couple of times, is the problem and why do we p-hack, and why, I mean, what's the issue of all those results that are possibly not replicable? That's often the statistical problem of the small ends, the small sample size, and this is a very nice illustration of it. I don't know if you see my mouse on this slide, but those are results. On the x-axis you have the year of publication, on the y-axis the Cohen's d, so an effect size measure, and the size of those cohorts are represented by the size of those circles, and that's here studying the association between the BDNF volume and the hippocampal volume, the BDNF variant and the hippocampal volume. And what you see, and that's something that has been actually replicated well, but a bit of time in different areas, is like early results maybe show very high effect sizes, and but with small cohorts, and then when you increase the size of the cohort, you see those effect sizes going down, and then to a point where there may be no effect at all. So that's the kind of Wiener's curse / p-hacking, like with small number sample size problem that I think we're still suffering from in many instances. And if you think that's only restricted to aspect of classical testing, this is probably not the case. There's a very nice study by Gail Varocco here that's showing that the accuracy across many data sets for looking at the psychiatric or neurology diagnosis, if you look at, if you try to predict those diagnoses, the prediction is going to be very good, very accurate with small sample size, with small cohort, and much less with large cohort. So that's phenomenon that you've just seen before with this effect size here is not restricted to the null hypothesis testing. It's also something that you can actually study and look at in machine learning techniques that maybe don't have enough validation tests, that have not been seen at all during the cross-validation procedures. And that problem is like compounded by the fact that we don't have enough sample size. Like, if you're looking at this paper by Russ Podrak and others, looking at, what is the size of the cohort that gives us 80% power for let's say, for a given sample size. So here, for instance, for the effect size that is that you can detect with 80% power in the medium effects in the sample size that is found in the literature in 2015 or 16 is about 1. So you can detect samples an effect size of 1 with the current median sample size in the cohort, number of subjects. And if you look at what is the actual effect size, and we were discussing this with the students just before, is that the effect size that in the HCP, which is a good data set, a good quality data set, those effect sizes for activation studies, for instance here, range really between like 0.3 to 0.7, but 0.7 is like a motor, bilateral motor, supplementary motor cortex. It's a huge, like a signal in the SMA. So really, so the thing we're looking at are probably around like a 0.4, 0.3, possibly even less, if it's an interaction. And the thing we are sort of like equipped to detect is probably more like of the order of 0.8 now or something like that. So when that's the statistical, I mean, some of the statistical problems, there are other problems, but at least I went through I think some of the major one. There is the issue of data and software that I want to think is very interesting. And I want to take that example because I always thought it was so kind of revealing. It's not in our field, but it's still a very revealing one. It's this example of that good researcher in crystallography that had inherited a little script to analyze the structure of those proteins, and had published like a really good journal, like in really good papers, like PNAS, Science, and so on. And all those papers had to be retracted because that script that he had inherited from a good lab was actually flipping the structure of the proteins. So basically, all those results were inaccurate and were wrong. And that script was, it's just a matter that why didn't anyone check that thing was doing the right thing? And it's very interesting sociologically, like if it was inherited from a lab that was doing really good science and really good publication, then you have the tendency to trust. And I think that's a natural tendency. That's it's a community, and checking is not in our kind of like should be in a scientific genotype, right? But it's not, apparently it's not enough. So I think that's an interesting, and the second example is really important. You really have to read that example. It's an example, it's the example of the Bagalian forensic analysis of the Potier et al. Studies. I think it's the key message here is that the initial mistake was because the software was used that had two arguments, and the first argument was in kind of a spreadsheet where you had to have the line of the headers, and the second not, and it was like a recipe for a mistake, of course. And the initial study was wrong because of that shift by one line, and then there was fraud and all those things. But I think the initial mistake was actually just pure mistake, and then there was cover up. But but don't think of the initial thing, which I think is the important aspect. And Bagali and Combe could never publish their stuff in the journals that Poti published in. They had to go to like a biostatistical journal that published their forensic analysis in 2 weeks because they thought it was so important. But it was important, like those at that stage, at that time when they started to publish those things, like there was actual clinical trial giving the wrong drug to the wrong patient because of this shift by one line, and the genes were not the right one, and so on. I won't go into details of that, but it's a very interesting, revealing story. And now, more recently, there's a bunch of papers that have occurred, we say, basically trying the same thing, which is give one data set to many labs and see what are the results. Ask them to, like in this instance for the NARS paper, ask them to, analyze, to test like a specific hypothesis between two experimental conditions in fMRI, and see what they come up with as a result. And the thing is that there's a lot of differences in the pipelines that were analyzed. Some were probably completely wrong, like maybe a small percentage. But even if the same sort of results occur, the answer to the question whether there is this an activity or not in that area between condition A and B is quite variable, even with those kind of similar-ish results. So that variability is kind of concerning, because we don't have a ground truth there, and we don't know which pipeline is going to give you the right results. So that pipeline variability is really concerning, and we've seen that in a number of cases. I mean, there's this the classic now Deflon et al. Multiverse procedure, where what are all the pipelines that actually will give me something the same sort of classification. And there's in my lab, like Nikhil Bhagwat, in a postdoc of mine, actually look at the variation of pipeline with respect to structural connectivity aspect between brain regions, and frankly, it's kind of like it's bizarre that there's so little. I mean, that those results can be so different across pipelines. Recently, Maxime Descoteaux and many other good researchers have actually look at tractography, and tractography, there's a lot of parameters to be tuned, and which one is good is unclear. And that's sort of a sample of the differences between tracks that you find using different pipelines. So there's also data issues. I don't want to go too much there, but I'm old enough that I remember the left and right problem in the analyze format image. But I'm still thinking that there are still some left and right issues sometimes. There's the obviously the data that are licensed. They are not well described. There's the QC is actually not reliable. The headers are not correct. All those things in the provenance. If you have time, go and I'll make my slide available. Go and look at this little YouTube video. It's very enjoyable. It's funny. It's also kind of true. So it talks about the how do you describe your data and why is it important to do so. So this is an example for NCP, some processing has been done, but unfortunately some bugs have been found, and then you have to retract and say, hey guys, don't use those data. There's a bug in those. I think the thing I want to emphasize a bit more now is why is it so hard to actually make something solid and replicable and robust? And that's I think it's a lot of it has to do with cultural issues. And the problem, I think, and many people are thinking like that, I'm not the only one, obviously, is that the publication system that we are living on is actually kind of problematic in some ways, because it is a bit of the only currency, but there's a really strong incentive for people to advance in their career to publish things, and there's a high competition as well. So that's fast publication and sometimes like a high impact things and therefore like a surprising or results is I think nurtured by the academic system quite a bit. So this is a study, for instance, that was done on the biostatisticians, and they were asked, hey, do you have sometimes when you're actually participating in a grant with medical doctors or biologists, do you actually ask to do some things or to say things in the grant that are not true? And the answer is that there are clear evidence that there are severe variations, and those variations are frequent. So there's a big social pressure for not only in publication but also in grant writing as well. So when I looked recently at how many papers in neuroscience were published, and you look at that graph, it's just a very simple PubMed. There's the amount of papers being published is just amazing. It's just like it's a deluge of papers, and I think that's part of the problem, and I want to dwell a bit in why that's the case. And the issue is most likely that publishing is a business. Unfortunately, I would say for us, it's an extremely profitable one. If you look at, for instance, the big publisher companies, and it's a major area of business. Like, it's between the movie business and it's comparable to that sort of business, right? And the profit margin for some companies at least is extremely high. So if you look at Elsevier, it was close to 40% profit margin, while a standard newspaper would be more close to 10%. And it's not clear to me and to others that the values and the objective of that publishing industry are really aligned with the objective and the values of the scientific community. And I think we have here a mismatch, a problem that is difficult to solve. So I want to talk a bit about that. And if you haven't read that very interesting historical piece on how that came across, how did Elsevier come across to be like major publisher of scientific journals, please read it's the Guardian long read. So it's if you look at if you Google that title, you'll probably find it. It's an extremely interesting historical sort of path of why the publishing aspect of the science was moved from the societies to an industry. And the key problem is that our research is mostly funded by non-profit or government, and then all the research is, and then we must pay again to actually have access to that research. And why is it so profitable? Because the work of the editors and the work of the reviewers are actually for free, and they're mostly for free. And basically, we can't actually get out of those journals because they have the reputation. So we kind of a hostage of that problem. So it's a very bizarre thing. Yeah, it's extremely interesting to think about it. So what can we do? There's a bunch of things. I'll talk about a couple of things that I'm thinking for myself and in more in general. So first of all, I think the training and the awareness aspect is critical. So training yourself in software and data management aspects, statistics, of course, but also the awareness of those, I would say, ecosystem, academic ecosystem aspect is important. I would say that myself, I like to choose my research projects a little bit with in mind those larger issues. So I'm trying to straddle between actual scientific project and also meta scientific project, if you want. And also kind of like think of being like a citizen of that ecosystem, of the academic ecosystem, and where do we engage in that in that society. And as an author, reviewer, an editor, the choice of where you publish, is also important. Can we like a push publishing aspect that will be better for science, our scientific goals. So I've engaged in the Reproducibility Center, which is led by David Kennedy. It's basically trying to build the tools and the training for more reproducible neuroimaging. And so there's a bunch of things that have been done at the neuroinformatics level. And one of those is really to try to extract and describe data, not only data, but also analysis workflow with a system that, locally you can have your metadata such that you know exactly what has been done. So it's a provenance model from the W33Prov specification. And those metadata telling me exactly what has been done on those derived data, where do they come from, what is the exact pipeline, and those things can be then shared across, those across institutions, across projects, and so on. So that is a kind of a long term and not an easy path, but I think a very interesting one. If the tooling, all those software, when made such that it is actually easy to do it, it doesn't take more than it doesn't take 50% of your research time. It takes on maybe only 3% of your research time. Then the ratio, like a value versus cost, would be demonstrated, and so we within the reproducing project, this is our kind of a long-term direction. And one of the things is that more locally, like if you take a bits data set, you can take those participant.tsv file, and instead of having like the columns called whatever the name of the column is, which is maybe age or gender or sex, or that those are kind of easy. But like whenever you have an assessment on instrument, then things can kind of start to break down. Then like exactly saying, hey, this column represents exactly this, and you can go on the web and see exactly that instrument and what it means, and basically take it again, and so that's kind of a harmonization and provenance aspect is important, and can be done with those emerging tools now. And hopefully, and this is linked to more like the ontological world that Lee is well aware of, with looking at exact terms in the intellects system and saying, hey, this term, this is exactly what it means, and this is what I'm annotating with. In the reproducing area, I've actually, my role is more on the training side. So if you are interested in training aspects in reproducing, like go and look at those modules. They are not great yet. We are hoping to improve, and we're hoping also that the community is going to be more like a community work to improve those things. But there are a bunch of little modules that are useful for reproducible neuroimaging. So especially there's the how do you use your computer and bash, which is, it helps to do a lot of reproducibility aspect, the fair data with the annotation aspect, the data processing pipelining, some statistics component, some p-value education aspect. And linked to that training, we're actually promoting quite a lot the NCF neurostars.org question and answer. It's a great community tool where there's a lot of expertise and there, and many of the good questions will actually find good answers. So I think it's just a little shout out to that to the NCF Neurostars. It's very good, and also very well attended, both by the quality and the quantity of people over there. Yes, so I work also on trying to develop infrastructures that will help reproducible neuroscience. I want to mostly talk about the CNPI one today, and the CNPI to me is trying to do probably too many things, but one is to look at big data sets and make that available, but also the small data sets. How do I document and make available those data sets such that if I have if I'm interested in Parkinson's disease, and I can go and search across many infrastructure where I can find a good Parkinson's disease and what's available. And there's a lot of money lost, I think, in all those little data sets that are not shared and not documented, or if they are shared, they're not findable because there's no way you can where they are and or to actually query the metadata. So CNPI is really trying to. It's a pan-Canadian grant, but led by Alan Vance on the side of both, or looking for something that is scalable but also interoperable. And the key aspects so I work on the technical and the portal and technical side of that project. There's also some training and some governance and ethics, so it's an interesting work across those things. The aspect of the interoperable aspect is that the key aspect, I would say, is that it is distributed across Canada, but beyond also Canada now. And what we've built is using DataLad, we've built sort of a metadata lake where all those data sets are represented, are sitting on where they are on their own infrastructures. So that's important in terms of the governance of those data sets. They're not centralized. All the data sets are sitting on their own infrastructures, and those infrastructures can be Zenodo, OSF, an XNAT database, a LORIS database, FRDR, plenty of different backend infrastructures. But we share the metadata describing those things, those data sets, allowing us to actually have a search across those things. But the data lab is actually giving you direct access to those files if you need those. So it's a powerful system, still under development, but still have it has a good sort of a first portal, and you can play with it. So if you go to the portal.cnp.ca, you'll see all those data sets, and you can play with the with search of data and those things. One thing that we did in this project is to reuse as much as we could international standards. And for describing a data set, there are many different standards. Schema.org is one. It's the one used by Google, but it has very little information that is mandatory. So we chose the DATS dataset that was developed by the BioAcadie NIH initiative to describe dataset. It was supposed to be the counterpart of a JATS model, if you know what that is, which is describing a publication. So publication described by JATS are in PubMed, and the dataset described by DATS would have been in DataMed. I don't think I think the idea is still really good, and we should pursue it. It's at least we are using the DATS model for the CNP data. And those it made me think that like if we want to communicate and make neuroscience useful and reusable, those standards are really a critical thing. Having a good standard to describe a data set. So BITS, for instance, is an excellent standard to describe a data set, not because it's the best technically. You will find many people, like saying, hey, technically BITS is really a bad idea for X or Y or Z reason. It is a good standard because it is used. It has a large community of people using it, and even a bad standard that is used, is way more useful than no standard at all. So I think that we have to think of those social aspects when even when we are in committees and we have to negotiate. Oh yeah, that's a good idea. That's a bad idea. Let's try to have a consensus, and yes, it's not going to be good and perfect, or certainly, I mean, maybe good but certainly not perfect, but at least it's the thing that everybody can use. So INCF is a really good organization in that respect, because they're kind of trying to have the criteria of what is a good standard, and in those criteria, and so they're vetting standards and saying, hey, neuroscience community, that standard is a good one because one, it's got good documentation, good tooling, it's been reused by others than the developers of the standard, and so on and so on. So I think a little shout out to NCF for this, because that's is a very useful and important direction. So to improve organization, so I've just putting that INCF plug here for the standards and best practices. I think that's, in terms of the reproducibility of neuroscience, that's one of the key aspects. One of the, I said that, I'm choosing research project that are a bit on this side of things. So one of the research projects that we're developing with Jacob St. Robinson and Tristan Glattard at Concordia is this scientific testing framework. Basically, if you had a specific question, let's say here, like we taking an example of the hearing loss and the size of the hippocampus. With that question, there's many different pipelines for segmenting the hippocampus, and many different data sets that have hearing loss and T1 images, and how many of those combinations are actually giving us some result that are holding. So creating that dashboard is one of those projects. So it has actually a question which is more on the hearing loss and hippocampus involvement and atrophy, but it is also a larger project in the sense that we're trying to see what would be reusable, robust across data set and pipelines. in terms of like data sets, I'm fortunate to work with Jérôme Doques, who is a postdoc in my lab, and Gaël, who is was visiting professor a year ago, and basically what we're looking at is the robustness of those biomarkers if you select a slightly different population. So let's say that instead of you learn a specific biomarker on the population that is a bit is a bit younger than another one, how is the biomarker going to perform on a different subpopulation that has slightly different demographics and so on? And that's so led a very interesting work for those interested in biomarkers and with their robustness with respect to demographics. I recommend to go and see that prevented dataset shift from breaking by machine learning biomarkers paper in gas science. The last thing I want to talk about is the publication model problem, and I think you sensed from me that I think that's one of the roots of the problem, and it's a very hard one to solve because that's a very sociological and community aspect and also big money aspect. So that one is a tough nut to crack really, but I think it's interesting to see where we can make some progress in a direction where we are a bit less dependent on the and possibly we can save some research money from the publishing industry. So one organization that I would really recommend that you look at is the Force 11 organization. It is called the Future of Research Communication and E-Scholarship, and that's really their business of trying to make a new kind of way of publishing scholarship, and so they really have good ideas and good tools and all those things. So and they're really like a proponent of FAIR and so on. So there's a number of solutions. I mean, like it's not a new problem. Like people have thought about it quite a bit. So there's the Plan S for open access, for instance. And one of the problems with the Plan S of open access is that if you at the moment, we have journals that have a version that is non-open and a version that is open. So the journal is making subscription from our libraries from the non-open access, and then is making the authors pay with the open access aspect. So it's really excellent for the publishing industry. They have like a double revenue there. But basically, the idea that you have to pay $3,000 and sometimes more to publish a PDF that you are the author of, that some scientific, some colleagues have reviewed, some colleagues have edited, and it's just put on the web. That is the problem that I'm thinking, okay, there's something wrong there. So there's a number of things and initiative. I will point to the DORA, the San Francisco Declaration of Research Assessment. I think it has and one of the issue is can we drop the impact factor, because the journals they have their brand and their impact factor, and that's what makes them their reputation is what they live on. But the problem is that we do need good sifting of research. We do, with the number of papers on, we do need some quality insurance, and we can't look at every paper with the same sort of a priori on the quality. So it's probably not like a reusable system. I think my take on that problem is that we really should reshift the publishing to be back to the academic societies, and that's what I try to do with the Aperture project with the OHBM. So we've put out publishing platform for OHBM, and that is kind of I mean, and in the text, in the kind of governance text, I make sure that the non-for-profit aspect was mentioned, because even societies would be very happy to make a lot of money with publication. So making sure that the governance of those things are visible and we'll have some oversight from the community is important. And with Aperture, we've tried to make something that has both high quality publication, and that's the problem. Like we need high quality publication because that is still something that is critical. And if you launch an open journal of a society that has very low quality, nobody's going to be interested, and that doesn't going to have an impact on the problem. So it has to be high quality, open access, of course, low cost, and publish things that are more diverse than just the PDF and more reusable than just the PDF. And I would say, again, the governance aspect, the community-driven aspect is important. There's a good series of journals through the NPRC of the INCF that I wanted to just point to that. There's a collection of journals for that. And we worked recently more on the on publishing notebooks, Jupyter notebooks. So publishing notebooks is not easy because it's not an object that people are accustomed to review. So in the traditional journal, people don't really know how to review those things. So neurolibrary is one of those things coming out actually of the CNPI and led by Pierre Bellec, Nicolas Tikoff, and myself on publishing, how do we publish and how do we review a notebook, not for the science, but for the technical aspect. And this is a platform that Elizabeth Dupré and I have been working on to actually mix the aspect of a binder, the Jupyter books, the open journals like a JOS, and the binder hub to actually create that neurolibrary platform where publishing a notebook will be possible and hopefully rewarded and interesting for the people to publish in it. And there's a number of things going on in this. So the number of aspects that have been reused, again, Jupyter books, binder, GitHub, and being used by eLife now, plus magnetic resonance in medicine, some other journals, and Aperture. So as a conclusion, there's in terms of reproducibility, I've talked about the pipeline flexibility problem. Do we want to reanalyze all the data set with like tens or hundreds of pipelines? And is that going to be sustainable? That's one thing that Nikhil Bhawat was looking at recently, and the answer is that probably not. We can't. So we have to find other solutions. It's probably not to be sustainable in terms of the amount of computation and the amount of time needed. So my takeaway message, the takeaway message I would put to you is, first of all, you can't ignore the environment, its incentive, the financial and power structure aspect of and that's not something that we can do by ourselves in our in our competing lab. So you have to have other mechanisms that bring people together to solve for those things, and also be careful. There's a lot of I have students that you also have to protect yourself in that area, because unless you're a tenure professor and you don't and you can do whatever you want probably. If you're a student and you say, hey, I'm going to write open source code and push the data out, and I don't care that much about my next paper, those students will have less chance to actually succeed in academia, and that whole system is going to be generating people that are actually not going to solve for the problem. So that's so I would like to say, try to think about the problem, but also work such that you are succeeding. I think that is important. And yeah, I would like to thank a lot of people and yourself for your attention, and be glad to take a couple of questions if there are any.
Well, thank you, JB. That was a great overview of where the field is at, problems we have, and sort of what we can do. So the room is open for questions, and people can feel free to put their questions in the chat as well. So I think maybe I can have a question for you, JB. I think your last point, right, about do what you can from where you are, but protect yourself as well. I think that's a really important message, But I think also, as faculty and students, trainees, we also should feel empowered to do it, right? What are some of the things that individual labs could do while still maintaining productivity and achieving the impact factor so we can get promoted and all that stuff. But that may be on the practical side. As you mentioned, larger samples can give you more robust findings. But for some of our groups, who are studying smaller samples, what are some of the practical things so we can do to make sure that our findings are robust, or our publications are replicable. There are some of the things that we already know to do, right? Like utilizing standardized methods for one thing, or describing your methods really clearly, publish your codes and data and so forth. And so I think these are the things that we're starting to learn to do. But do you have additional advice or thoughts on students, especially who are getting into this field recently?
I think it there's one thing that you can also gain recognition and kudos and reputation from sharing data and code. Like some of my students, they're very well known in the field because they're participating in Nylon or fMRI prep, or like things that are extremely heavily used. Have a lot of a lot of a good reputation, and they will find good job and good postdocs, and through that mechanism as well. So it's not entirely like a bleak place, and also if you share a good data set, like let's say you push it, you tweet it, people will see that good work, and actually, if it's a really ambitious data set in some ways, you can publish it, like let's say in Scientific Data, or some other journals that accept data set descriptors as and I think it's a great way of you have to acquire the data, you're acquiring the data. It's if you can actually make use and have a publication that is recognizing and that work, I think it's kind of evaluate the work at the level of the academic scholarship, which it should, and I think that's those directions are definitely possible.
Thank you. Also, feel free to just unmute yourself and ask questions. I have another question, JB.
I think Charles. Yeah.
Oh, I'm sorry. Did someone raise their hand?
Yeah. Sorry, I'll jump in. Hi, JB. That was a really great talk. I really enjoyed it. This is something that's constantly just gnawing on me. So my question is, do you know of any studies that have actually measured the reproducibility of pre-registered studies compared to non-pre-registered studies?
I don't, and that's a very good question. I don't even know if we would have the numbers, Charles, because first of all, we'd have to have replication. I mean, first of all, replication studies are scarce, right? So there's not that many of those. Pre-registration studies are scarce as well. So if you multiply those two small numbers, you might not have the the amount of publication to actually have a proper answer to that question. But that's a really good question. I would love to see that. There's some studies that show that there's a more chance of results to be, I think, reproducible when data and software are shared, for instance. So that's in that kind of direction a bit. Not exactly the same question, but close. So yeah, I think that so I don't think we have the answer to that directly.
Yeah, and then, so if you don't mind, a quick follow-up. You mentioned the move towards open access being kind of like a long-term solution, but a short-term difficulty because it essentially just increases the revenue streams for many of these journals. Do you think that seems, I mean, my kind of gut feeling is that seems to be the most likely implementable route that we are going down. There seems to be a lot of support for it, like the NIH is slowly moving us in that direction. Do you think that that is the kind of thing that we should really be putting our weight behind to try to push us in that direction? Or yeah, maybe speculate is, I guess, maybe my question.
Yeah, no, it's a good question. I mean, the issue is to me it kind of like it patches something which is important, which is the access and and when we say access, like we're thinking also of other countries that have less revenues, and and if you are from a small lab in I don't know, India, or there's very little chance that your university is going to have all the pay for all the journals, and so I think it does, and not everyone is going to Sci-Hub, and but so I think it does patch a problem. I think it doesn't solve for the problem that the key aspect is that the people, I mean the organizations are in charge, have one main goal, which is making sure that they have large revenues, which is absolutely not a problem in itself. It's the goal that companies want to make money is perfectly legit. People have to have job, and I'm not an anti-industry person, it's but the problem is that this industry is in charge of how, and there's no real competition in some ways, because we are kept hostage of this journal reputation aspect. So basically, there's no, in a competitive world, I think we would pay, $500 per journal per publication in science, right? And not 6,000, if that was really competitive, because but it's not a competitive world. It's like you have if you are called Cell, you are called Cell, and you can make anyone pay a lot of money from a rich lab because it's so important to have a cell paper.
Yeah, thank you very much. I really enjoyed your talk. Yeah.
Do we have time for
one more? Okay, Rushika. Okay.
That was a great talk, JB. I think I wholeheartedly agree with almost everything that you said. One of my struggles as a mentor is recognizing the privilege that I already have. So I'm a full professor, I have an established lab, and I have all of those things. And so, we have these pipelines in our lab that every paper that gets published, a second author reproduces that entire analyses and the stream independently on their own, but it slows down progress. Right? So how do I, as a mentor, balance this need for reproducibility and making sure that our results are at the least reproducible and hopefully replicable as well, but then also ensuring that my mentees are getting the publications and getting the number of publications and the quality of work published in the short duration that I have. And this is balanced by the fact I lead a clinical lab, so my trainees not only do research, but they also have clinical work that they tend to do. So I think it's a question that I struggle a fair bit with as a mentor, and was curious, how do you work with your students on that?
I don't have a good answer, I'm afraid, but this one is a struggle I have as well. One of the things that I kind of do, and I tend to make sure that the students that I take have a route outside of academia. So, there might be less people that will be staying in academia because, there's but yeah, I try to be not too take too much risk for the students themselves, right? And also to explain, what are the different things that they could do. So that's the short-term aspects, not taking someone that or actually train those people with data science aspects that I know will be good in the community industry or outside of academia. So that is one possible answer. The other answer that I wish for the that's more like a long-term thing, and is engage in those publication or organization that try to make research objects that are not just the narrative and the study, but also the the software, the pipeline, the data, like a noble research object that have have their own impact factor, important. So like a scientific data impact factor is, I think, 6 or 7. I hate impact factors. I mean, I'm not saying that it should be used, but what I'm saying is that people will look at scientific data as like a good publication, and that's just a data set. So pushing a bit on that direction whenever possible also is a partial answer. But I think the struggle will be will still there. Will be there. Yeah, there's definitely not a full answer to that problem.
Thank
All
you.
right. Well, thank you, JB. Thank you, everybody.